Okay. Hi everyone. Um, Hi there. Welcome to my video. Um, so this video is about a project that I've been working on known as Beacon. And this is a real-time vehicle or fleet tracking system. So it's basically a dashboard where you can track vehicles on the map. You can see their current location, um, in real time as well as their previous routes, right? So I'm just going to go through how, I built, most part of the application, but I'm going to be starting from a higher, level of explanation. Um, so I'm going to start with explaining the architecture behind everything. So let's go, shall we? Okay, so I'm going to start with the parts that we have for this web application. There are various parts, and I'm going to start with drawing the path for the. First of all, before I even start that, let me just show you a demo of this project. Okay, this is not working. Yeah, let me just show you a demo of it first, so you can see what we're talking about. Oh, okay. So yeah, currently I have three vehicles. I'm just one saying a journey. Yeah, okay, started. Yeah, so this is what we have. We have three vehicles on this map, and you can see how each and every one of these vehicles are moving. Um, oh, this one is not taking one way. Okay. Okay, so this one is along Shagamu Road. Um, and I think it's going towards Ikorodu, I think. We have another one along Lagos Ibadan Expressway. I don't know where this guy is going to because we are only traversing around Lagos, so we are not going to Ibadan. Anyways, we have the third one, which is around yeah, still along Igodo Road, and I think this is this is this Maryland? Well, okay, okay, I can see Yaba here. Okay, I think it's around like Maryland, Anthony. But yeah, this is the idea of what we have. We have this is the idea. We have different vehicles on the map, and you can be able to tell the pass routes. I think the last 100 points. Um, then you can also tell from here. You can tell yeah, that's basically it actually. And this is basically what we have. You can also add a new vehicle if you want to, but you need to add the vehicle, then attach a GPS. And once you attach a GPS to it, they just spawn up that vehicle on the map. So that's just a demo of what this app is about. And let me just start with the explanation on how the entire thing works. I'm going to start with the moving parts, the parts that we have on this application. First of all, we have I'm going to have, I'm going to say we have the simulator. Very important. So this was the first problem that I encountered because I wanted to build something that was, in real time, tracking vehicles in real time. And vehicles have GPS, right? But I won't be able to do that without I don't have any vehicles with GPS on the road. So I had to create a simulator. Come with the idea of creating a simulator that would you know, go through, drive through Lagos and I'll record the telemetry data like that. This is actually the most interesting part of the project. Like I learned a ton. So this is one part. Second part is this is just the API service. All right, this is just backend. Like uh, let me just call this backend service. Packed backend service. And then I have my database, which is DB, and my clients. Yeah, so this is just the browser. Okay, so these are all the parts that we have um, for this application to work. And I'm just going to start explaining how everything connects into each other. So for simulator, there are two major parts of the simulator. I have the graph builder, um, graph builder, and I have the movement engine. And I'm going to explain what each and every one of each of these parts do, going to explain the responsibility. What is this graph view? Okay. All right. So can I group this thing? Is it possible? Oh yeah, I can actually group it. Nice. All right. So we have this part, simulator and the graph builder. So what is a graph builder? Um, so first of all, because we are dealing with, the goal is to have vehicles moving around Lagos. And for that, I had to get the map of Lagos, right? I think OpenStreetMap provides something, I think it's a protocol buffer binary format file. It's a OpenStreetMap file. It's a compressed file that contains all the road network in a particular location, right? So in this context, Lagos. So what I did is you take that file and run it through the graph builder, and the graph builder, just maps everything, takes everything out, extract the needed information, which is just builds out a graph. And then we now, have this, we now have the movement engine that basically just traverses the graph. Um, but that's basically what these two do. These two, that's what they do. And what I'm going to explain here is the first thing that we do is after. So when we start the application, the simulator starts, the backend service starts, kicks up, right? And then the simulator makes a request to the backend service. It says, "Hey, what's up? Give me the list of all the GPSs that we have." Okay. Give me all the list of GPS that we have, and okay, I think what I should do is let me move this to this place here, then move this to here. Yeah, give me the list of GPS devices that we have, and so I can, so it collects the list of all those, GPS devices, and then it basically then starts the movement engine for each and every one of these GPS device. So the first thing it does, this movement engine, first thing it does is it gives every GPS device a random start position, and then an ending position. So what they do is each and every one of them, they drive to a destination, and then once they get to that destination, do a random pickup of a new next destination. They drive to that destination, and it just keeps going on and on and on and on until maybe we turn off the application or something just fails. But yeah, that's basically the idea. And while doing that, there are a series of things that happen. We have to calculate the bearings, to be able to determine, what's part of the map the vehicle is facing. We have to do a lot of other things I'm going to explain when we start reviewing the code. But yeah, that's basically what the simulator does. And for each vehicle, we have, certain, go routine for per vehicle. So that means that when you start up, when when I say vehicle, I also mean GPS, right? So when you start up a movement engine, it spins up gives a vehicle a go routine and says, okay, you just deal with this vehicle for us. Whatever operation you're doing, whether it's moving or whatnot, you deal with that. And that helps makes the entire system kind of like really scalable, because you don't have to now have one process dealing with all the vehicles. You could have like 1,000 vehicle on the road now. You don't want that situation, right? And so that's basically what I'm going to touch on about I'm going to talk about the on this simulator part. The next part is, so after this backend service has sent all the GPS devices to the simulator, does all the graph building and then starts the simulator itself, which is the movement engine. And then the movement engine, while we are traversing the graph, we're getting the coordinates of each vehicle. And as I get that coordinates, we're sending it somewhere. We're sending it to the backend service, right? That okay, this is our updates on this particular GPS device. Do something with it. Now, the backend service takes that data, that telemetry data, our fake telemetry data, if you can call it that, and stores it in a database. I'm currently running a Postgres database, so it stores that in a database. I'm going to talk about the design of this database. It's pretty straightforward. Just three tables. So it stores that in a database, and then at the same time, it shoots that telemetry data to WebSockets. Um, Let me just call this WebSockets. And then WebSockets then broadcasts that to the browser, right? So that is basically what happens here, right? So we have again, what should I think I should just move this one to this part here, Jerry. Okay, yeah, I think it's better this way. Yeah. So we have the simulator, retrieving GPS device from the backend service, and then sending telemetry data to the backend service to store. Backend service is giving that to DB to store the telemetry data. At the same time, backend service is sending the real-time telemetry data to the browser using WebSockets. That is the entire thing that happened. That's just how this whole thing works, right? Um, and so I said I was going to talk about the DB. So that makes the entire thing real time, just basically mainly because of the WebSockets, but also because we have an events driven architecture here because we're making use of server sent events. So what I was doing previously is when I start a simulator and when they add a new vehicle, I would usually poll on the back end every 10 seconds, but that wasn't very efficient. So I had to swap that for a server side event. So what that means is we subscribe to an event and we just listen to when there's a new vehicle that's been added to the backend service. And then from there, we just instantaneously send that information and the vehicle just instantaneously just appears on the map. And I can show you that here. Let me just add a vehicle. I'm going to call this vehicle VEH04. Let me just say it's a car and vehicle. I can come to GPS. Let's just say GPS 004. And I can give it this. And once I click it, all you have to do is just wait for a while. And yeah, we have this vehicle here, and that's always started the journey. So if we even check the telemetry data here, we can see that GPS, the ID4 is already sending new information. And that is now in turn being, displayed on the map like this. All right. Let me dive into the database architecture. So for the database, we have a concept of we have three tables basically. For the database, I have vehicle, right? Now vehicle has the ID, it has the plate number, and I think it has a created at column. Right. Let me just extend this. How do you even extend? Like, how do I even resize this thing? Okay. Yeah. Okay. And then we have the GPS device. And this GPS device is stable. It has an ID, it has the serial number of the GPS, and I think it has a created ad also. Right. Oh, also it has the vehicle ID. It has the vehicle ID. That's vehicle that is attached to that GPS. And yeah, that's all. And then we have another table called the GPS. Is it GPS points? Something like points, right? So this is what's storing all those coordinates as it's moving along, storing each and every one of those, telemetry data. So here we have the ID, we have the longitude, we have the latitude. And just to get a quick glimpse of what we have here, longitude, latitude, we have the bearing, we have the GPS ID, and the timestamp. So we have the bearing, the GPS ID, and the timestamp. And it also has created as. Now I'm thinking about it, I don't think we even need both of them. We can just use one, but no, that doesn't break anything. So I'll just leave it at that for now. So yes, this is what we have in the database, and the relationship between a device, a GPS device, and a vehicle is just a one-to-one relationship. But for the points, GPS, and the vehicle, we are storing. Wait, am I storing the vehicle ID? No, no, I don't want to store the vehicle ID. So I'm just storing the GPS ID because the GPS owns the points. And so that's basically what we have. So if I show you let's take a look at what we have at the GPS points. You can see that for every data, for every thing that is being stored, we have the ID, bearing, latitude, longitude, GPS ID, and whatnot. And that just helps us keep track of where the vehicle is on the map. Let's see where this guy has gotten to. So as you can see, this guy started, something's going on here. Let me refresh this. Let me refresh and see what's going on. Okay, that's been corrected, huh? I have to figure out what's going on there, but yeah. So this has been corrected. So you can see this vehicle started the journey all the way from here. This was the first random start position, and it has driven all the way to Lagos Abeokuta Expressway. Pretty nice. And you notice something that these vehicles are not just jumping from one point to another. They are actually following the pathway, the road in Lagos. And that is all thanks to the movement engine, some things that I did in the movement engine. Um, just to show you what we have. CMD, simulator, movement engine. And that has to do with this, the BFS path function. This alone handles the correct movement of the vehicle. So the reason why we have this is we wanted to find the first instance. What I was doing is I was picking, every time I was picking a random next point to move to. So let me explain this way. We have, so imagine this. Imagine a situation where we have we had node A, right? And then we have node A, node B, node C. These are the different location points of nodes that we can move to from node A. Now you can move from node A to node B, node to C to D. But notice that sometimes the vehicle would move to node B and back to node A, then maybe to node B, then to node C, to node D, and then maybe again back to node C. So there was this back and forth that was happening. And so I figured out that what was happening is because I was picking the position at random, the next the next position, the next location at random, it wouldn't make any sense that way. It would just like be moving around very weirdly. So what I had to do is determine how to move them in a linear way, and that is where this comes into play. And this basically uses the breadth first search algorithm, which is an algorithm that finds the shortest path to destination. So because the goal is now like, oh, we have a destination ahead, we need to get there, but we have to keep picking the next, the shortest possible route to that place. And so that just deals with the linear movement that we have now. Um, and then we have the compute bearing. The bearing is just what helps us to determine where the vehicle is facing. Is it north, is it east, is it south, and to what degree? So that just helps. This just helps with that. That is why we're able to see that when the vehicle is moving, or wherever a vehicle is, it faces the exact place. It's the exact what I call it, bearing, the exact place that it's moving towards. So even if I end up turning the map, it doesn't disrupt that yet. So that's all thanks to this compute bearing and also some little bit of stuff on the client side. And here we have the closest node, which just helps us to find, closest nodes from one point to another. Then we have this function that just picks up the random node, and we have the drive vehicle method. This is the movement engine itself. This is what moves the vehicle and sends the telemetry data to the backend, and then we have the backend storing it and sending to WebSocket and whatnot. But yeah, that's basically what we have on this project. It's not. It was a very interesting project. It wasn't. And I learned a lot, mostly about bearings and distance and formulas and whatnot. Some maths were done on this, but I just wanted to share this interesting thing. See if if you're interested in going through the repository, feel free, check it out, and maybe give your inputs on what can be improved or not. So if you have any questions, feel free to hit me up, and if not, ciao. Have a great day. Bye.